That's why I left teaching, you see. I just couldn't get that right. That was it.
You're not going to ask me about
using
mutual exclusivity, are you?
Okay.
I mean, I know it.
Hint taken.
I mean, it's like mutually exclusive is P of A plus P of B. What is it?
Created using Powtoon. Created using Powtoon. Created using Powtoon.
welcome to Teaching Mathematics. Today we're joined by Robyn again. Hello, Robyn.
Hi, Helen. Great to be back.
Yes, good to have you. And we're talking about grade 11 probability.
Grade 11 probability, yes, that's right.
Well, we'll probably have a good time.
I hope so. At least, well, I suppose the chances are about 80%.
So cheesy.
It was likely that Dylan would say that, but...
Well, as you know, probability is all about fun
Yes.
and games, so we're going to have a lot of fun in games.
Oh,
this,
good.
this webinar.
And of course, Dylan is behind the buttons. Thank you, Dylan, for solving all our problems and getting us online. Not that there are ever any problems. It was a joke. It was a bad one, obviously. Okay, so you're here, but you have been here before. But just in case someone hasn't seen you before, why don't you tell us a little bit about yourself?
Well, I work at WITS in the education campus, and I lecture maths to teaching students. And before that, I was a high school teacher for 6 years.
Okay, and I'm assuming high school maths.
Exactly.
Yes.
Maths and maths lit.
So you really like maths.
I
Did you
do.
like maths at school?
I think I did. It's quite far back to remember. I remember enjoying the challenges, but not the homework.
Okay.
But I think that many students are like that.
Yeah.
They enjoy a class when it's challenging, but not when they have to do things on their own.
This would be an interesting survey to do amongst us maths teachers. So if you're out there, why don't you tell us whether you enjoy doing maths as a student and why you started being a maths teacher? And Dylan will watch the Twitter feed. Remember, it's #MEMaths. And he'll watch the Facebook page, so watch there. Also, we have a chat box underneath the live viewing window. So if you scroll down from where you can see us, just underneath, you'll see that there's a little chat box on the left for maths. Choose a nickname, something nice, and then click log in and start chatting.
And we'd love to hear from you.
Yes, and of course, if you do chat with us and it is a good chat, you could win 110 rands airtime. So do that.
Wow, it's a pity we can't do that.
No, it is a pity.
What are the chances of us getting any airtime? Absolutely nothing.
Yes, that would be a good place to introduce the probability scale. If you don't have a phone and you win the airtime, I know a great way you can win a phone or a tablet.
Really?
You can put down your great teaching resource into an email and send it to us, competitions@digitalclassroom.co.za, and then you could win a phone or a tablet. And it's a Sony Xperia L and a Samsung Galaxy tablet.
Wow.
10.1 inch, I think.
That's amazing.
Yes, it's good prizes.
So get clicking and
Yes.
send us your resources.
Yes, just watch out for the secret code. That will appear somewhere at the bottom of your screen at some point, and write that down. Put that into your subject line so we know which show you were watching when this happened. It can be a resource that's inspired by this show.
It could be.
Do you feel like being inspiring this morning? Or
Well, I'll try to be.
afternoon?
I'll try to be.
Good. Okay, before we go on to all of the content, as you know, I've been reading that book, Teach Like a Champion. Yes, and I'm now on technique 16 out of 49. And this one is called Break It Down.
Okay.
And at the beginning of the chapter, they say it's quite a difficult step to explain because it's actually in response to a poorly understood concept or a skill that's going wrong. So you can't go into a lesson and go, okay, now I'm going to break it down. Yo. It's my gangster coming out. So
Never thought there was any chance of that happening with you.
So you've got to go in there, you do constant assessment, and remember, assessment doesn't only have to be written down, and then you see where someone's going wrong, and you remedy it. But what they do in the book is they suggest different methods, and the methods were really, really good, and we could spend an hour talking about them, but we're not. What I'm going to say is that you should read the book, especially step 16, because I think this has been the most worthwhile step out of all of them. Go and read it and give us your feedback. Tell us what you would do. Or even you could tweet in now. Say, what do you do when someone doesn't understand?
Well, this has made me really curious about the book because I really want to know what those various techniques are. So I'm going to go home and take out my copy and read it too.
Oh, well. Okay, now you are talking about probability today.
I am talking
Yes.
about probability. We're talking about grade 11 probability. And probability is all about the chance of something happening.
Yes.
So,
There is a misconception that probability only relates to gambling.
oh, absolutely not. It can relate to getting up in the morning and deciding what to wear. The probability, well, every day we look at the weather to see what the probability it is of it is going to, if there's going to be rain, wind, snow if you live in the northern hemisphere.
Or actually in Cape Town at the moment, they're forecasting snow this week. So
Oh, really?
Sorry, Cape
Oh, wow.
Townians.
Sure.
Yeah.
I wish I was in Cape Town to play with some snow. Although I don't like the cold. So.
No, me neither. But I know also when I'm driving to work and it's a long drive for me, I calculate I don't do it accurately, but I think about the probability of me getting into an accident versus the number of cars that are on the road, and then how they are driving, what speeds, how that affects the probability of an accident happening, and, cheerful thoughts.
Wow. I mean, when I drive to work, I think, what's the probability of me getting to work on time versus the number of robots that I have to go through on the way to work? And what's the probability of me getting to work on time if I leave 5 minutes late, 10 minutes early? And sometimes I find that if I leave 5 minutes later than I usually do, I actually get to work at the same time because the traffic has died down a little bit. So
I think it's important
very
to introduce this in the class. Just say, this is where it's going. This is what you can do with it, especially because it links up to your high-paying careers, like your insurance brokers and the actuarial scientists who work with statistics and then work out probabilities after that. Yeah, just to highlight it, say.
Well, my husband works in the insurance business, and they had a particularly bad year last year because of all those very intense hail storms that happened. And we had stones the size of tennis balls at some point last year. I think it was the last summer season. And that, in terms of probability, it was a very small chance that would happen. And they're banking on it not happening again for a very long time because it really is... should be something that happens very seldomly.
Shame they've been hit by the earthquake this year.
Exactly.
Things are not
looking good for insurance companies, no.
Okay, shall we look at your 5-point teaching strategy?
Yes, so the first point that I put down here is that we should revise grade 10 concepts. And the one that I think is particularly important is experimental versus theoretical probability. So experimental probability would be... What is the probability of something actually, or what would actually happen if you did the event? So that would be if I tossed a coin 10 times. Theoretical probability says 5 times I would get a head, 5 times I would get a tail, but in real life, when you're actually doing the experiment, it might be slightly different. But we find that the more times we repeat the experiment, the closer it comes to theoretical probability. So I think that's very important. And when we get to grade 11, we start to move more into theoretical probability than just doing experiments. Experimental probability is used mainly in grade 8, 9, and 10 to introduce the concept of probability. By grade 11, learners should understand what probability is. It's all about chance. And we move into doing more calculations with theoretical probability.
Okay, your next one says identifying the difference between dependent and independent events and using the product rule.
Well, dependent and independent events are very important, and this has got a lot to do with the the problems that we see with drawing marbles or coloured balls or coloured counters out of a bag. Or taking socks out of a drawer, and many times the condition will be with replacement or without replacement. So that's the difference between
I just had yes. We were talking earlier about Venn diagrams and Venn diagrams that were more fun than other diagrams and things like that. And your sock example would actually be a really good Venn diagram, because I'm thinking now my socks what are the probability, never mind of matching socks, but finding socks without holes in them. And then you compare that with the number of matching socks you have. So you have red socks, blue socks, socks with holes.
Socks without holes.
Yes.
Yeah. So a dependent event is when your second event depends on something that's happened already. So, for example, if you've taken out a sock out of your drawer, that then the probability of when you take out another sock out of your drawer changes because there's now less socks in the drawer. Whereas an independent event is two events which do not depend on each other. Let's say, for example, tossing a coin and throwing a dice. The throw of your dice isn't affected at all by your outcome of tossing your coin.
It might be an idea to, when you say the sock example, taking one sock out, keeping it out, and taking out another sock, to say, well, how do we turn this into an independent event and get them to then answer?
Well, you've got to put the sock back.
Yes.
But then you'll still only be half dressed. You'll only have one sock on your foot.
Yes, problem. But it does kind of get the idea across that a dependent event can become an independent event if we put the thing back in.
Sure.
In some cases.
Sure. Yes.
Yes.
I think that's especially important when you play games. And often you draw counters out of a hat to see who starts first. And if you've drawn a counter out of the hat to say that you start first, you want to keep that. Like
Scrabble, when you choose the letter and I've got B, I'm not going to put B back in because it
will give your friend a better chance of getting B so that they'll start before you. Yeah.
Yes.
So it has very many practical applications.
Okay, the third one says Venn diagrams and the intersection and union of events.
Well, I love Venn diagrams. Venn diagrams are always so interesting. And I think I'm going to just draw a little picture of a Venn diagram and talk about intersection and union. And many learners are not aware about the intersection and the union of events.
Yes, carry on.
There we go. We'll have a look on the slide.
Yes.
And if we look at the second picture labeled number 2, that's the top one on the right-hand side, we can see that is the intersection of events because it is looking at A and B.
Okay.
It's looking at both of them together. And then if we look at the very bottom one, number 6, it's the bottom one on the right-hand side. That's looking at the union where it is only... Sorry, I've gotten them confused.
Okay, the intersection is the
intersection is and, so we're looking at the bottom right-hand side, and the union is or, so it's looking at A or B, which is the top right-hand side.
There we go. Okay, well, let's go back to your 5-point teaching strategy.
There it is.
The fourth point says tree diagrams and using these events that require replacement or non-replacement.
So tree diagrams are a wonderful way of illustrating a probability problem because it kind of gives us a picture. And like I always say to my classes, draw a picture. It really does help you to draw a picture. And so with using tree diagrams, we always put out branches each time there's an event or an option for an event. And then if a second event happens, the tree grows to a second set of branches. If there's a third event, the tree grows again to a third set of branches. And the number of branches shows how many outcomes there are in an event. And I think the important thing about replacement and non-replacement is that, as you know, the branches of a tree can be represented using fractions, right? So if I say there's 10 balls in a bag, what's the probability of choosing a red one? If there's three of these balls inside our bag, then the probability of choosing a red ball is 3 out of 10. But as our branches grow, if we haven't put back the ball that we chose into the bag, there are now less to choose from. So it's very important that learners understand that the denominator of my fraction will get smaller by 1 each time the branches grow because we are taking balls out of the bag. And I think that's quite important.
We did speak about this briefly last time, about my problems, and they are personal problems. My personal problems with using marbles instead of other things.
Sweets.
Yes. And I'd still like the idea of using sweets in a bag, because no one ever puts a sweet back in the bag, except for maybe if it's the green one. Yeah.
Oh, well, I would put back the yellow one.
Okay. Well, there we go. So if they take the sweet out, they know they're going to eat it, and they know the number of sweets in the bag has also greatly reduced.
Sure.
Yes.
The only problem with talking about sweets is it makes you really hungry. So if you're a teacher, you really do have to bring a bag of sweets into your class to help demonstrate. I think that's very important.
I think so too. And once again, it ties the memory of the tree diagram to
really
the food,
does.
and
it really does.
that would make it
Jelly
easier
tots
to
is
do.
also a very good kind of sweet, because there are many jelly tots in a bag and they're all very small.
You know, the problem with this is that then you've got too many possible outcomes. You've got red, you've got orange, you've got green, blue. There is a yellow jelly tot as well.
I think so.
So you've got all of those, and that's a lot of tree diagrams. Maybe what you could do is or branches in the tree diagram. Maybe what you could do is rather talk about complementary events there, and you say, what is the probability of picking a yellow versus the probability of not picking a yellow?
Yes, exactly.
And then that's two different outcomes.
Well, we have an example like that coming up a little bit later.
Oh, good. So we'll revisit this.
We will get there.
Okay.
Yeah.
Now, the replacement and non-replacement, that's dependent and independent events again.
Sure, that's right.
Okay, so it's just using different terminology
Yes.
to explain the same thing over again. Okay, the fifth one says two-way contingency tables and how they help us with independent events or mutually exclusive events. Now, I've noticed in some textbooks they call them two-way tables, and others contingency tables.
And I just put both. I called it a two-way contingency table.
Yes.
So two-way contingency tables talk about usually it's a situation of testing or combinations. So the one that I found to be most interesting is looking at HIV tests and looking at male and female populations. So if we have a two-way table, the number at the very bottom right-hand side will give us the total, and then on the very right-hand column and the bottom column, it will give us the totals of
Examples a lot more interesting than the standard grade 11, grade 12 who takes maths and maths lit.
Exactly.
I think every textbook has used that table.
Sure, exactly. But the great thing about two-way tables is that they really are used in real life. And I mean, if you have a look in newspaper articles, especially on health reporting and that sort of thing, two-way tables are a great way to start becoming literate in not only... many learners say that, when will we ever use maths? Well, probability is the one place where you really will use it.
And yet we put so little emphasis on it in class.
Yes, it is.
It's almost swept under the carpet. I was just about to say, my mom is a radiation oncologist, and she does a lot of testing with different drug companies. It's not human testing, it's just trials. That's what it is. And then she needs to report back on how they worked on different people. So she's got to say the males responded this well, females, and then her contingency table is really, really useful. Yes.
And it actually provides a very lovely way to summarize data as well. And then using your data from each intersection, according to the total number of participants which are tested, you can find out the probabilities. Where
and that would, of course,
lies.
be a fraction, a decimal, or a percentage.
Yes, and that will take me actually to my next point.
Yes, 3 pressure points.
One of my pressure points is that the concept of probability being both a decimal or fraction and a percentage, and I think many learners confuse that very much. They don't understand that our probability scale goes from 0 to 1 or 0 to 100. 0 to 1 if we're looking at it as a decimal or a fraction, and 0 to 100 if we're looking at it as a percentage.
Yeah.
And we need to know that if I get a fraction of 7 over 10, it's the same as 0.7, and it's also the same as 70%.
I've just had a thought.
Mm-hmm.
Do you think we're disadvantaging them by giving them their marks in percentage in terms, because then there's a comparison. If you get 70% for a test, you know that's a good mark.
Mm-hmm.
But if there is a 70% probability of it raining, they don't really understand what. Maybe that's a bad example, because that 70% chance of it raining is a strange.
It is a strange probability, because
Yes.
I've heard two different interpretations
Yes.
of probability of rain. If you say 70% rain, some people say, oh, it means it's going to rain for 70% of the day. And on the other hand, some people say, well, it's going to rain in 70% of the area that
Yes.
that the forecast covers. So it's going to rain in 70% of Johannesburg.
Yes.
So it won't rain everywhere, but it's likely to rain in 70% of the area.
And it doesn't actually measure an amount. It just
Exactly.
measures an
Exactly.
area.
Mm.
So, yes, that is a poor example to use.
Well, going back to your to the example with learners and tests, I always give my learners their tests back in a fraction, their mark out of the total mark, and they have to convert it to a percentage themselves. It's another way I train my learners to convert from fractions.
It's a
to
very good idea.
percentages.
I wonder if they had to do it in decimals, would they be able to derive meaning from it? If they get a test and they say, okay, well, I got 0.35 for it, do they know that is just barely scraping through?
Well, I think that we've really, just because of convention, we've really trained our learners to look at things in terms of percentages. But when I do my marks on a spreadsheet, I always do convert their mark to a decimal. So, for example, 0.35, and then multiply it by the weighting of that test in
Yes.
terms of the overall mark structure. So maybe I should ask them to give me their. I'll give them their mark out of 50 or 100 or whatever it is, and they need to give it back to me in a decimal, just to test.
Yeah.
Mm.
Okay, number 2, difficulty with dependent-independent events.
Well, I think we've spoken a little bit about this, but I want to speak some more about it. And this is really looking at events and how they affect each other. So, for example, a completely independent event would be throwing a coin, throwing a dice, and we can see that the one outcome has absolutely nothing to do with the other. Whereas something like a dependent event would be, what is the chance that I'll go walking today? And it's dependent on the weather, so it's a 70% chance rain, 30% chance no rain. If it rains, there's about a 5% chance that I'll go for a walk. If it's sunny, there's about a 90% chance that I'll go for a walk. What is the overall probability of me going for a walk? Well, that's really heavily dependent on what the weather is.
Yes. That's a good example to use.
Mm.
Because once again, it takes it away from cards and gambling and all of those things, and it puts it into a real world situation.
Yeah, I don't like it that many textbooks just focus on throwing coins, throwing dice.
It's the same
picking a
example
card.
from grade 9 all the way to grade 12. What are the chances of finding a king?
Or a red king, for that matter.
Yes. But it's a personal issue once again.
Mm.
Okay, number 3, knowing the terminology is important, e.g. sample space, event, outcomes.
Well, we can move on to the next slide for this. And I've listed some of the terminology. And many of the learners get tripped up because they don't know exactly what each term means. And they tend to get bogged down by all these new words. So I think that a very important teaching step would be just to go through all of these terms and make sure that learners really understand it. For example, the sample space. What is a sample space? What is an event? When you have an event, what is an outcome? Can there be more than one outcome? What does mutually exclusive mean? It's really important to really get into the depths of these terms to make sure that learners really understand what they're talking about. I mean, I don't know if this has ever happened with you, but many times when I spoke to learners, they would get up and they would say, and the mutually exclusivity of this event, and they speak about it, but they don't really know what each of these terms mean. So I think it's
important that they can talk about
that. Learners can first of all understand what each of these mean, and then talk about it in the correct context.
Yes,
and use it correctly in a sentence.
I'm making an educated guess here, and I would say that most teachers struggle to remember what these are, because we're all teaching probability right at the end of the third term or the middle of the third term.
We're tired. It's getting to the end of the year. Got to start setting exams. It's a difficult time.
I work with content a lot, and I have to go and look up these terms to make sure that I'm using them in the correct context, even though I do work with content all the time.
I'm exactly the same. I completely understand where you're coming from, and I feel the same. So I think a great strategy for teachers would be to list all the words that need to be looked up. And, well, there are many different ideas, but the one that I would use is get learners to go in groups of 2 or 3 and each get allocated a term, and you could just do this quickly in one lesson. They get to research it either on the internet or using their phones, or if you have a set of dictionaries or maths dictionaries. And then for 5 minutes or maybe 2 minutes, each group gets to report to the class. An event is something that happens where there are outcomes.
Okay.
You know, although I'm sure your learners will do a much better job than me.
Have you tried doing this?
I haven't tried doing it with probability, but I have done it with other sections of maths. It gets a bit rowdy sometimes, and you do need to be able to keep a bit of control in your class. But it's also, I find that it's a fun way of learning, because learners get to find it out for themselves. Whereas, I mean, when I was a student, I just hated when the teacher put up lists and lists of terminology, and I had to sit there for an entire lesson completely silent writing it down. So I think it's a better way.
The other groups, I mean, if Sample Space Group presents theirs, do they listen to the others?
You see, that is a concern. I find that most of the time they do, because in order to understand the section, you need to know the terminology.
So would they be making notes?
They should be making notes, yes.
And this would be the one time. It's not like you're going to then provide notes afterwards. They know that this is the one time they get to make notes.
Sure.
So it puts weight on the shoulders of the people who are presenting to make sure their definition is correct.
Otherwise, sometimes what I do is I'll collect the definitions that each group has provided, collate it into one single worksheet, and then photocopy it for
No,
the
I
whole
like
class.
this other idea better.
So do I.
Because it takes the responsibility.
And puts it squarely on the shoulders of the learners.
Yes, and as a teacher, you should be walking around and monitoring that they they're heading in the right direction. But the students should be making their own notes. They're grade 11. They're 16 going on 17.
Yeah. I find that a lesson like that might not work for grade 9s. They're a little bit more rowdy. But by the time learners get to grade 11, if they are interested in passing, many grade 11 learners, in fact, you should tell grade 11 learners that matric isn't 1 year long, it's 2 years long. First year matric is grade 11 and second year matric is grade 12, and that's how they should be seeing it.
Yes.
And many learners then do take grade 11 quite seriously.
As a teacher, I think it's a good idea to have these words with the definitions stuck up as opposed to at the back of the classroom. So as you get stuck on the words, because everyone gets stuck on union and intersection and which symbol
one is
which. But as you get stuck, you can look up and you go, oh yes.
With the U.
Okay, you can get the naughty badge for today. Well done.
Thank you.
Okay, now you've got some examples for us.
Yes, I do. Let's go on to this first slide. Oh, well, I've titled my page So Much Fun, because I think that the best way to teach probability is about having fun in games. So my first game is, if you pretend that you are at a fair and you could win a holiday for 2, which game should you decide to play? And this is a great way to get learners to interact with each other and work in groups. And there's 5 different games here, and they should calculate the probability of winning each game and decide which game they should enter. So there's 5 different games, and I'm just going to read them out. The blue one says, you will win first prize if you can toss a fair coin and get 12 heads in a row.
Ooh.
Wow, that sounds really difficult.
Yeah.
The green one says, choose the top 4 from 10 famous pictures and put them in the right order to win. So obviously, we can find some sort of resource on the internet, and we find 10 famous pictures. I'm sure Mona Lisa would be one of them. And in which order are they in? And if you can choose the top 4 and put them in the right order, then you'll win.
Okay.
This is a bit of a counting problem, actually. And then our yellow one says, our resident gardener has listed her 7 favorite plants in order. If you can match the order, you can win.
Should we?
Sure. And then the orange one in the right-hand corner says, throw 5 fair dice and get 5 sixes, and you will win the first prize. And then the pink one says, you toss 4 10-sided dice. Wow, a 10-sided dice. And you will win first prize if you get 4 sixes. So the aim of this task is for learners to decide which game they will have the highest probability of winning.
Yes. Okay, I would twist it around. I would show them the slide at the beginning, and I would say, okay.
Play these games.
No, I would say, now you need to design your own. Your group over there needs to have a probability of 20% or 0.2. Put it all as decimals. Get them working.
Get them working in decimals.
Yours needs to be 0, or you don't say it verbally. You give them a little envelope.
Yes.
So each group gets this magical probability that they need to then find an activity that matches that probability. They then do make that activity, whether it be words or an actual activity, up to the discretion of the teacher, and then submit it so that the other students can then work through it. So they're practicing working with probabilities, and maybe it's an end of chapter exercise, because then they can utilize the tree diagrams, the contingency tables, the mutually exclusive events and independent and all sorts of things like that.
Well, building on your idea, what you could actually do is, if you have a spare day, I know spare days are very hard to come by in grade 11, but if you do, after each group has designed their game, they get to go around and play each other's games, and it's a great way of having a look at the differences between experimental probability and theoretical probability.
You know, grade 12s need to do a portfolio.
Well, this could be a very good portfolio
task. Yeah. Something different for the teacher to do.
Something fun.
Yes.
Exciting, and hopefully worthwhile as well.
Yeah, please let us know if you've done anything like this.
It would be great to find out.
Yeah, you could win a phone.
Or a tablet.
Yes.
Or airtime.
Yes, that's true. The next one, coloured balls.
Well, I got this from my favorite website, and I'm sure that the URL will be put up at some point.
On the blog, yes.
On the blog, yes, it'll be up on the blog. And it's from a website called Enrich, which is a British website, actually, but they have fantastic resources. And this is having a look at a game, and if you have a bag of coloured balls, and each ball has a number on it.
Yes.
And we get to pick 2 balls randomly from each bag. And if the sum is even, well, you win. And if the sum is odd, you lose. Is this game fair? What do you think? Just have a look at it quickly, Helen.
If the sum is even, you win. If the sum is odd, you lose. Okay, in order to get an even number, you've either got to add 2 even numbers together or 2 odd numbers together.
Correct.
Oh, I don't know. I'd have to calculate it.
We would have to calculate it, and there's actually 2 ways to calculate this. And so it asks the question, is the game fair? So we would know that the game is fair if there were an equal number of odd outcomes and an equal number of even outcomes. But if you do the calculations, and unfortunately our whiteboard isn't working, so I'm just going to have to explain it. We can do this in 2 ways. We can either make a table and list all the possible outcomes, which is 3 plus 2, 3 plus 4, 3 plus 5, 3 plus 6, 2 plus 4, 2 plus 5, 2 plus 6. And there end up being 10 outcomes. And when we look at it, this game is actually unfair. And if you're sitting at home, why don't you quickly make a table and see if you can see the different outcomes?
Now, you see, I would do it differently. I would say we can get an even number 3 ways.
Correct.
Yes. And an odd number, 1, 2, 3, 4 ways. Okay. I'm just fiddling in my head. I'm not sure where that thought was going. I was getting lost in the maths.
That's okay. There are 4 even outcomes out of 10 and 6 odd outcomes out of 10. If we have a look at it. Yes.
Okay.
Yes. 3 plus 5.
Yes.
1.
2 plus 6
2
is
plus
another
6.
one.
2 plus 4. And 4 plus 6.
Okay.
So there's 4 even outcomes, and there are 6 odd outcomes. So
4 plus 3, 5 plus 2, 5 plus 6, 2 plus 3. Yes.
Yeah.
Okay. Yes, Dylan.
Just a quick thought. The way that you can quickly work this out is even numbers are formed by the sum of even numbers or odd numbers.
Well, we're getting there, and you're jumping the gun,
sorry,
Dylan.
I'll be quick.
That's okay.
So this is all coordinated.
Okay.
Unfortunately, we don't have our whiteboard, so we can't show it. But so first of all, if very basically, you could just add all the numbers together and see that it's a pretty unfair game because there's fewer even outcomes than odd outcomes. But as Dylan was saying, another way that we can do it is we can say, well, the way to get an even number is an even plus an even, and Helen, you were touching on this, or an odd plus an odd. So if we have a look at it, to get an even number, and this is now working with replacement as well.
So dependent and independent.
It's going to be without replacement because we take one ball and then we take out another ball. We're not putting any of these balls back.
Okay,
right?
I'm
Because
pausing
we're
you there
picking 2
quickly
balls.
because the question doesn't say that. So if this were an assessment, it would actually be an unfair assessment because we hadn't told them if we were replacing the balls or not.
Well, I beg to differ because I think it's implicit because you're taking 2 balls. You're taking 2 balls out of your bag.
Okay.
Right? And then you're looking at the sum of it. Nowhere does it say that you're putting any of the balls back. So I think it implies that it's a problem that has non-replacement.
Okay.
Do you disagree with me?
I do, but I see your point. Maybe this is something that you should say explicitly within your classroom.
Yes,
So
I think it is a
if-
good idea. The less chance for kind of miscommunication or misunderstanding, the better.
Yes, Dylan.
Or is this not a teachable moment to leave it vague and fuzzy
And see what learners do.
and explore the different outcomes in each case?
Well, perhaps you could say make one situation with replacement,
Yes.
do another situation without replacement, and compare the results.
Yes. Okay, so yes, I paused you in the middle of talking about even odd.
Yes, sorry. So what I wanted to say is there's a situation where you can use an intersection, which is and. You could get it, union, which is or. Now I'm confusing myself.
I know that feeling.
Because we could get an even number by saying 2 even numbers or 2 odd numbers. So
Okay.
to get an even number, it would be, well, how many evens are there? 1, 2, 3, 3 over 5 times, and if we've taken an even number, it will be then times 2 over 4, plus, if we have an odd number, it's going to be
Oh, I see. So you're finding the probability of picking 2 even
evens.
numbers, and you're adding the probability of picking 2
2
odd numbers.
which would result in an even number, and finding that probability.
How
And-
about this? You talk
Mhm.
about complementary events, and you say we know that by picking 2 even numbers or picking 2 odd numbers,
Mhm.
what is the probability of picking. No,
Losing?
it's you
Finding
see,
an
it's
odd
the
number?
same process,
It is
isn't
the
it?
same process.
It's
yes.
not complementary. It's just tackling it from a different
different
way.
angle. Correct.
Yes.
So then the second, the lower half of the page then gives us a whole lot of new situations and asks the learner to choose which set of playing balls that they want to play the game with, because they obviously want to win. Obviously, everyone wants to win. So whenever we look at different situations, we want to try and find out, the most likely chance of winning.
Yes. Okay. This might be a good activity to do with your class before you tell them that they must design their own probability game. Because
Yes.
it will give them an idea of something else they could do to get an unusual number for probability.
Yeah, and this is a great game because it's fun, it's interesting, and it forces learners to think a little bit out of the box.
Yes. Okay. The next one, using tree diagrams. 4 people are asked to pick a number between 1 and 6. What is the probability that all people will choose a 5? And I'm going to go straight to the next slide.
Give me a
okay.
second, because I want to ask you, Helen, what would you do? Would you draw a tree diagram with 6 branches because you could get any outcome between 1 and 6 because you're throwing a dice?
Okay. Robyn, I must be honest, at first I would, and then I would look at it and go, no man, this is rubbish. And then
Because drawing a tree diagram with
6 branches.
four branches, 6 branches 4 times is going to result in an absolute chaotic mess.
Yes.
Am I right?
Very definitely.
Absolutely. Because, I've had learners who take up an entire double
Yes.
page drawing tree diagrams with dice and drawing 6 branches. And then on each branch, there's 6 branches. And then on each of those 6 branches, which there's now 36 branches, drawing 6 more branches. And by the time you've gotten to the 4th event, there are 6 to the power of 4 branches on the end here. And that is just completely impractical. So that's my hint to teachers. When you get a question like this, instead of showing each and every single outcome, you're actually looking at 2 outcomes here. You're looking at throwing a 5 and then throwing anything else that's not a 5. So rather just make it 2 branches. And now I'd like you to move to the next slide.
Okay.
So instead of drawing 6 branches with 6 branches each, we can have a look at this diagram, and it actually is just showing 2 branches each time.
And it looks incomplete.
Can I just make an interjection there?
Sure.
That 6 branch times 6 branches all along. Would you use, or would you allow learners to go down that garden path just so they can see the folly of their ways, or is this something that you really can't afford to waste the time on?
Dylan, that's a very good point, and I think that that's why I tried to explain it like that before we moved on to the correct tree diagram, because I think learners sometimes do need to make mistakes in order to learn. So I think it's a one area where you can say, okay, how do you think you'll do this? Draw 6 branches, and then by the time they're on the 3rd branch, and there's so many of these little spider webs crawling across their pages, and they have no idea what's going on, then you can say, well, is there a simpler way of looking at it? And there most definitely is.
The reason I say that is one of my maths teachers at school kind of drummed into us that good mathematicians are lazy people.
Yes.
And they're always looking for
a shortcut. You must have had the same math teacher as me. That's the way exponents were introduced to me, in fact. We're too lazy to write down y times y times y. We just use an exponent.
Yes.
And fundamentally, mathematicians are always, I wouldn't say lazy, I would say efficient. Yes, exactly. Mathematicians are always looking for more efficient ways to show something.
Okay, it does look incomplete.
Well, the thing is, Helen, once we get a 5, that's all we need. All we need
The
to know.
question says, what is the probability that all people will choose a 5? So shouldn't we have all of the branches going out from those 5s, coming down, and then going down?
Have I done it the wrong way? Should be switched?
Yes.
Yeah.
So
Because-
we could change the text to say, what is the probability that all
no
people...
one will choose a
Yes.
5.
That
Thank
no
you.
one will
There we
choose a
go.
5.
That's-
Okay.
I got the tree diagram right, but not the question. Because
Let me guess, you win all the arguments at home.
absolutely.
Oh, good.
This is one of these situations where you remember the punchline to a joke, but not the actual joke.
They weren't
So-
my curtains. Yes.
So what the question meant to say was, what is the probability that no one will throw a 5?
Mm.
Because as soon as someone throws a 5, it's
not
finished.
worth
It's
carrying
not worth
on.
carrying on.
Mm.
Correct. Thank you for picking that up.
Now, that can also be tied into the conversation of, those people drawing 6 by 6 by 6 by 6 forever and ever.
Mhm.
Then they're going to go to the 5 and not 5, and more than likely they're going to draw all of the all
yes.
of the 5s as well.
Mhm.
And then you can say, well, actually,
You
you
don't
could
even
have
need
done
to
this
carry
in
on.
1 minute.
Sure, you don't even need to carry on those branches, because as soon as somebody throws a 5, well, game over. We
They're
don't
out.
even need to. We don't even need to carry on the tree diagram.
Yes. Okay, and this.
Well, now we get onto Venn diagrams, and Venn diagrams are just fantastic. And if you Google funny Venn diagrams or Venn diagram jokes, you will just see so many Venn diagram jokes, because Venn diagrams are just the perfect way to make really funny jokes.
And you know what's nice about them is that some of them, the funny Venn diagrams, they're borderline inappropriate. And teenagers love borderline inappropriate. So
Exactly.
you showed them something that maybe shouldn't really be shown.
But it really does, just pique their interest
Yes.
or tweak their
And they
curiosity.
will remember that, whatever it is.
Yeah. Well, we've chosen a very safe one for today, and we're
Yes.
looking at flour, eggs, and milk. And as we can see, when we mix flour and milk together, we get batter. When we mix flour and eggs together, we get pasta. When we mix eggs and milk together, we get an omelette. And
All
if you're
together.
really lucky and you mix all 3 of them together, you get just the best meal in the world, a pancake. And that's a wonderful way of understanding a Venn diagram.
Yes. I think it makes a lot of sense to do that kind of thing because, let's face it, when you look at a whole lot of numbers in some circles, it looks like numbers in circles. It has no meaning.
Sure. And if you have a look at just this Venn diagram, you've got 4 recipes all in one picture.
That's true. I was like, where's the 4th one? Oh, it's the pancakes.
Exactly.
Okay.
Yeah.
This does make me cringe a little. We did come to it a little earlier with showing the union
intersection
and
of
the
the union.
intersection.
Mm-hmm.
How important is it that they understand what an intersection is and what a union is?
I think it's very important, Helen, and I've included these worksheets. It's this one and then also the next page where there's now 3 options. But let's just go back to this one over here. You see, Helen, when you get numbers all of a sudden and you don't understand how a Venn diagram works, it's just so much more difficult and it gets really complicated. So I think this is a great way to start off Venn diagrams, and it's good to be able to name how each region is shaded, so learners are able to understand what a union is, what is an intersection.
Well, let's go back to the previous one. And now it would be a lot easier for me to understand it if we applied it to this example, the union and the intersection, and subtracting one from the other and adding them together to find something. That whole, if we go back many, many slides to where it says the CAPS document, the complementary rule and the identity.
Identity. Sure.
And the independent events, how that test and everything, it makes a lot more sense if I have the picture to look at,
Sure.
and then I look at those formulae as well.
And understand how they work. So let's go back to the eggs, the flour, and the milk. And
Yes,
so there we. Oops,
almost. There we go.
So if we look at, let's just look at flour and eggs
Yes.
for now. If I were to say the union of flour and eggs, the union of flour and eggs is some flour, a little bit of pasta, and some eggs. But if I just say the intersection of flour and eggs, we're looking at only pasta.
Okay.
So intersection is flour and eggs together.
Okay.
Makes pasta. Whereas if I'm looking at the union, it's like flour or eggs, right? Union is or. So it's including flour and a bit of pasta and some eggs. Does that make sense to you?
No, Robyn, I'm sorry. I'm going to have to Google it later to make sure that I'm on the same page. Because once again, I've got myself wrapped up within myself. I didn't bring a cheat sheet with me.
That's okay. Maybe I can try one more time.
Okay.
If we're looking at the intersection,
Yes.
it's where the two circles overlap.
Okay.
And only where they overlap. So that would be pasta.
If we look at these other pictures over here, would that then be number 6?
Very right.
Okay.
Totally correct. Whereas if I'm looking at the union, which is or, I'm looking at either A or B. It doesn't matter. It could be both. And that's looking at picture number 2, the one
So
in the top
it would
right-hand
also
corner.
include the intersection.
It would also include the intersection. Whereas, there isn't a picture with both A or B.
No.
Go back. If you go back one. There we go. Whereas if we look at the first picture,
Yes.
that's going to be B and the union of A and B, but not A.
Okay.
So
Okay, so there is a part of me that's thinking, well, B is just that whole circle, including the intersection part with A.
it is, because if you have flour and eggs and you take away the flour but you still have the pasta, there's still a bit of that in there, if that makes sense. Oh, I'm going to get very many people getting very confused about recipes and Venn diagrams. if I
Okay,
explain it
so
like
what
that.
I'll do is I'll find a YouTube clip and put it also in the blog that also explains all of this. One
Sure.
that makes sense to me as well.
And I'm sure there's a mindset resource on intersection.
That's very true.
And union.
That is
So
very
I think
true.
you should
In
put that
fact,
up on your
let's
blog
go
too.
look at it quickly. I just happen to have one. I feel like one of those baking shows now. I made this earlier. Yes, we've got 5 videos, not 6. 5 videos in the classroom resources, and it's basically the classroom resources section is where we teach things for the first time.
Sure.
That's what the focus is on it. They're 10 minutes long, roughly. But then you've got the Learn Extra resources as well. And then you've got an hour long of worked examples, and that's fantastic.
wow.
So you're not just learning the concepts for the first time.
You can
then
also work through
practice and
examples.
practice and practice. So yes, using Venn diagrams would have all of that information in it.
Wow, I'm so glad you have that resource available for the teachers, Helen.
Yes, it's a great thing. Okay,
I think we should both go and watch it too when we're done.
I might have to. Okay, so we'll put that up on the blog. And then you've got Venn diagrams over here with 3 circles in them.
And this is once again lovely for learners just to understand exactly how Venn diagrams work, looking at the intersection and the union and the sample space and all the different events.
Yeah. Okay. And this last slide says a survey was conducted to determine the preferences for 3 different types of music: rock, classical, or jazz. And I don't like this example because it only lists rock, classical, or jazz, and I know one teenager who likes classical music.
Really? And the rest don't.
Well, the rest don't like rock or jazz either.
Well, Helen, I think that then question 4 is
Yes.
just the question for you, because it says there 134 people did not like music at all. And I want to ask you, is the statement true or false? Motivate your answer.
So then you talk about the ones that don't like rock, classical, or jazz, but they do like music. They just...
Their options weren't available. Hip-hop,
Yes.
kwaito, R&B.
Mm-hmm.
Yeah. So I think this is a very good question to make learners understand that even though there are different choices, rock, classical, and jazz, in the sample space, there were 134 people who didn't answer positively to any of these 3 categories.
So they just didn't like...
So that 4th question is very important, where it says 134 people did not like music at all. So it's very important to say false. There's not only 3 kinds of music on this planet. There were only 3 choices in the survey, but it's not a reflection of real life. In fact, I think if we were to draw a Venn diagram of all the choices of music in this world, we'd be spending a very long time trying to do that.
Yes, try and fit all of those circles in. Now, in the last 5 minutes,
Yes.
or even 2 minutes,
Mm-hmm.
I would like to make a plea out to maths teachers who are creating tests and assessments and new questions and things like that for various examples that should not be used in probability just because they've been overused. Use something that's exciting and innovative.
Exciting. Yeah.
Yes. If you're doing grade 11, stay away from your coin
Cards.
toss, your cards, your marbles in a bag. Sweets. I like sweets. You can keep those sweets. And also, fruit. Who likes bananas, apples, pears? Please no. No more. And no more tuck shop examples either.
Oh, no. And contingency tables, no more grade 11s versus grade 12s, maths versus maths. Let's think of I know that is a real life situation, but let's think of a more interesting real life situation.
Something that will really grab them. Yeah. And yes, and last time you were here, which was 2 weeks ago,
Mm-hmm.
we found that site which had all of those ideas of different statistics you could
data.
use, and
Mhm.
you can use those in probability examples as well. So I'll paste all of those same links into the
your
blog
blog.
again, and you can find them in the grade 12 show or in this grade 11 show. Go and have fun and send us the resources. Send us what you've done.
We'd really love to see what you guys are busy with.
And please do something interesting. Make it fun. Get them to find a probability thing.
Yeah. The most wonderful way of getting great resources is to ask learners to do it themselves and
Yes.
get learners to create the questions, because they are uninhibited by years and years of using the same textbook and the same examples.
They don't have the predetermined ideas of what
Exactly.
is.
Exactly.
Yeah.
Yeah.
And I find that a lot of teachers also avoid using the lottery examples, because now it's 49 numbers, and I've now got to work with something out of 49 plus something out of 48. Plus it just goes on, and it's too much, and it feels too big. Don't
Don't shy away from the lottery, because it might be too big for your calculator, but it's definitely not too big for an Excel spreadsheet.
Yes.
And I would often work with lottery numbers, and I think what the chances of you winning is something like 1 in 13.2 million, if I remember correctly.
Something like that.
Something like that.
But listen, one day is one day.
One day is one day.
Yes.
Go buy that lottery ticket.
And it's a really good idea then to talk about experimental probability versus theoretical, because, theoretical says there's no way anyone ever is going to win that. But
Well, there is 1 in 13 million chance.
yes.
But talking about winning the lottery, you have a much better chance of winning your Samsung Galaxy tablet or the
Yes, that's
Sony
true.
Xperia. So please don't forget to tweet, Facebook, or comment on the little box.
And send us your resources. Yes. Okay. Any parting comments from anyone?
Well, I really enjoyed that. I think we had 100% good time today.
Yes. Thank you very much for joining us. Thank you, Dylan, for working your magic. And thank you for coming, Robyn.
Thanks, Helen.
Join us again next week when we'll be discussing grade 12 mathematics. Goodbye.
Created using Powtoon.